When do we give these back to you?
Oh, you have them, we'll just collect them at break. So thank you for reminding me. I would have walked out without those, without remembering those.
How
So
would you give them back to us tomorrow then?
what's up? I know, that's the thing. I looked at a whole mess. So yeah, I'll go through, take a look at those and just, go through, and if there's any like sort of last sort of minute stuff or things along those lines that to go through and consider. I'll work on those this evening, get those cranked back. Probably won't have like full final scores on those, so, but we'll get those back, and then if you want to give those back to me like Friday, then I'll go through and actually get those scored. So it's a lot of back and forth, but that's all right. We're making it happen. Okay. Questions on any of this?
Do you want the problem sets in your mailbox or Matt's mailbox?
My mailbox is fine, or just come drop them off. You can drop them off in my mailbox, or if you're like right there at the end, I'll be sitting in my office, just swing by.
Okay. Shoot him under the door.
Right, just like,
One page at a time.
let's not do one page.
My pocket too big to slide under there.
That's true, double-sided pages. that's
Okay.
why.
Got it.
Okay, one thing too, I will say, think about thickness of this, for your last set, right, or for problem 3, I'm having you go through and having you go through and hand calculate stuff. Your interpretations on those should be incredibly brief, right? Like you don't have any like actual information about anything that's going on. I just think it's a nice, like, you don't have to know what the variables are in order to provide general information on stuff, right? So this is just a boom, 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 this is what's going on. Just want to give you some practice. And again, to demonstrate that if you know what's up, like you can go through and pull a lot of stuff out of just like raw summary data that's provided in published papers, which starts to be really, really helpful, because not all the people aren't always going to give you the actual information that you want, but if they've kind of done a good job of reporting, you can go through and get that through secondary stuff. So yeah, that should be that last piece. I mean, if you find that you've got paragraphs of interpretations on that, you've probably gotten the wrong direction. You just don't, there's nothing, you don't know what the variables are or what's going on and things like that. So there's only so much you can do. But like I said, anytime you see an interaction, you should be able to give an interpretation to that interaction. Same thing if someone's like, oh, this is significant. That just means that something is likely not zero, right? Just with general information, I sort of can go through and make inferences on that. So those ones should probably be need. Yeah, if you've got something quite long, find me, because you probably got something right.
My only question with that was when I was reading through it, my typical interpretation pathway is like including S and VFBs, but I don't think we can really calculate those
Nope.
confidence intervals.
No, don't need to worry about that. I mean,
Okay.
those are all just, yeah, you're just factoring stuff out. So just practicing, sort of factoring out models and simple slopes, just because it's something that it's easy to get turned around on. So just want to give you some practice with those. Cool. All right. So going to talk about mediation stuff today. And that even, that's a loaded word, mediation. We spent Johnny's entire McNair project trying not to say mediation, because people get really kind of worked up with that. But what we're going to go through today is talk about conceptually what's happening in terms of mediation, what we're thinking about, how to go through and test it, some different sort of limitations of different types of designs and things to keep in mind with these types of analyses. All right. All right. So I guess in terms of just overview, we're going to start with kind of the conceptual framework for mediation. This is kind of a classic framework. And then we're going to go through a classic causal models approach, right? This is not something that you will probably do ever at this stage of the game. There's really no reason, because we've just got better ways to go through and do it. But I really want you to understand sort of the conceptual background for sort of why we do things the way we do now, as opposed to some of the old school stuff. So we'll talk about limitations, talk about indirect effects, and then quickly sort of final slides on reporting and extensions of how we can start to build together mediation, moderation, put those together to get some really kind of cool ways of going through invariable relations. Okay, so just like before, so after a while we get to a point, our regression models are great. regression models are really cool, but once we've been in an area for long enough, we start to wonder like, well, is evidence of a unique relation between X and Y really all that interesting, right? If we've replicated this time and time and time again, I don't know, it's not news, right? But again, with a standard regression model, we're kind of limited in what we can say about the nature of this association, right, between these variables. So again, given strong evidence for an effect in the population, we've seen something that's been replicated over and over and over again. One thing we might start to ask is certainly a question of like what factors might start to account for, or maybe even cause or explain an association between X and Y. X and Y is associated again and again and again and again in all these different papers. I might start to wonder why are they related? What are the mechanisms? What are the causes? What causes X to be related to Y? Okay. And this is where we get into our mediation. Okay. Mediation, we're talking about, and this gets into the tricky piece of this. Anytime in psychological science you start talking about cause, people are going to get really upset. Okay, or some people are going to get really upset because the question is, can we demonstrate cause? What evidence do you have that this thing causes that thing? Fair questions. And so then we get into history of experiments versus correlational data, sort of things along those lines, different ways of going through and analyzing. But anytime we're talking about a mediation analysis, we're talking about some sort of mechanism or cause. If we can dance around it, we can use different words. But at the end of the day, conceptually, that's what we're talking about. Okay. And so mediation from sort of a objective standpoint is looking at whether some external variable causes or facilitates an association between X and Y, right? We might not say cause, but that's what we're saying. If we sort of look between the lines, that's what we're essentially talking about. So a mediator then is any variable that accounts for a relation between some X and some outcome Y. Okay. And this is the kind of the standard graph that we use to go through and take a look at this. We've got a relation between X and Y. The relation in a classic full mediation, the only reason that X is related to Y is a function of this mediator. If we pull this mediator out, if we control for that, X and Y are no longer related. Okay. Which is different than our moderation, right? Our graph for our moderation says X and Y are related, and then our moderator changes the nature of that association. We're not necessarily saying that it causes it, right? We're just saying that this is some factor, maybe a risk factor or some other characteristic that changes, or a contextual factor that changes the nature of these associations. Our mediator says, nope, this is the cause. Now, if we start to get into more involved stuff, we can have variables that are both mediators and moderators. And some people will then start to talk about sort of the actual mathematical distinction of these starts to get a little bit blurry. We're not going to worry about that so much here. Just know that if it comes up, that is in fact something that is a real thing and is pretty cool. We're going to keep it simple for what we're going to do this semester. Okay. So examples of mediation. I can say the relation of attitudes with behavior is mediated through behavioral intention. Okay. So if you're working with Sean does behavioral intention stuff, right? We're saying the reason my attitude is associated with behavior is through my intention to act on those attitudes, right? If I don't have that, these two things aren't related. This is the only reason that those two things are related. Not really, but in a simple world, right? We're saying that we've got behavioral intention is mediating the relation between kind of what I think and what I do. We could say for clinical folks, this is a trauma thing, positive effects of EMDR on functional outcome are mediated by non-direct exposure. EMDR, if you don't know, is I'm going to treat your PTSD and I'm going to wave my finger in front of your eyes and you're going to track it with your eyes and it's going to magically rearrange your brain so that your PTSD goes away. It's not actually how it works. It's an effective treatment, but it's effective because we're having to talk about the trauma, right? Finger wagging thing is inconsequential, right? So we're saying that what's going on, the reason that we get positive benefits from this treatment with outcome is through this specific mechanism. Okay. People get a handle on sort of what we're talking about here in terms of the conceptual model and how it differs from our moderator. Good. yeah.
So would a null hypothesis just be like the relationship or the relation of attitudes with behaviors is not mediated by behavioral?
It's a little bit more complex. I mean, that would be, you could be could be your hypothesis. That wouldn't necessarily be a null hypothesis, just because we have to take a couple of different steps to go through and sort of pull that out. So conceptually, yes. Mathematically, that starts to get tricky. Okay, so hold on to that question, because we'll go through and look at the formal hypotheses for each one of the steps. All right, so once we hit sort of the 80s, right, people started to become sort of interested in getting sort of access to analytic tools and starting to become more interested in like, oh, hey, so what are the specific mechanisms and things along those lines? And so Judd and Kenny come out with a seminal paper that lay out this causal steps approach. Okay, so we're interested in testing what people are now calling mediation. How do we go through and test this? Judd and Kenny have a really simple model. They say these are the things that we need to be able to demonstrate in order to infer mediation. One, X has to have a significant relation with Y. Okay, X and Y need to be related. If X and Y aren't related to one another, there's no reason to have mediation, because how do I find a mechanism of a non-existent association, right? So step one, we need to have some base relation between X and Y. Okay, if we don't, then I don't know why we're talking about mediation when I don't have an association to mediate in the first place. Then two, Judd and Kenny are saying that each variable in the causal chain impacts the variable that follows it when all prior variables are controlled. Okay, when we're looking at, so this little label here, so X has to demonstrate a significant relation with Y. Okay, so I have to have this C path here has to be significant. Second, if I go through, I say each variable in the causal chain impacts the variable that follows it after controlling for everything else. Well, here in our causal chain, we have X causing our mediator, right? And so the only thing that's in that part of it is just those two variables. So we have to have an A path, okay? And then we also have to have a significant B path, but this is B controlling for X, right? So we controlled for that C path there, okay? So Kate, this is what gets into your, what are the null hypotheses? It depends on which step we're going through, right? So for part one of Judd and Kenny's original conceptualization, we say that C can't be zero, okay? And then for part two, we're saying that both A and B can't be zero, okay? And then the last part of this in Judd and Kenny's original approach is saying that X demonstrates no relation to Y after controlling for our mediator. Okay, so once I've controlled for the mediator, this thing is out. Okay. Thinking about in terms of examples, right? If I say, I use this in my example in my intro psych class, I say that pavement temperature is associated with drowning deaths, right? So if I go through and measure the temperature on the pavement, drowning deaths go through the roof, right? But probably when we're looking at that association, we're not thinking that the temperature of the pavement is actually causing people to drown, right? That's an association. Why might pavement temperature be associated with drowning deaths?
Like outdoor temperature also relating to people swimming more often.
Yeah, right. So if we go through and we account for swimming behavior, once we pull that out, is pavement temperature related to drowning deaths? Nope, because this accounts for it all. This is the whole reason those two things are related, right? Same thing if you say like the position of this switch is related to whether the lights are on and off, right? If I go through and account for the cords that sort of connect those two things or the electricity, once I pull that out, I can flip the lights on and off. It has nothing to do with whether the lights are on and off here, right? So in Judd and Kenny's original conceptualization, they're saying that we need to have a relation between X and Y. We need to have X related to the mediator and the mediator related to the outcome. And then once I account for that mediator, there should be no longer any association here. This is this C prime path, right? After I control for the mediator, there's nothing going on here. people see conceptually how this is starting to build to making an inference about identifying some cause of this relation. All right, so that was like the OG paper. Then Barron and Kenny come out with there's some problems with this. Barron and Kenny come out with a slightly different reformulation here. That says, okay, we're gonna make a few tweaks. What we need to see is that X and Y are related. We need to have a relation to mediate in the first place, right? I can't talk about something that's a mediator of, I don't know, hair color and the temperature of oceans in Australia, because those two things aren't related to one another. So there's no reason to be talking about a mechanism, right? So we still need to have this, okay? And we still need to see that X is associated with my mediator, which makes sense. If this is the causal thing, then that should be related. And I should say that the mediator demonstrates a relationship with my outcome, okay? But here's where they go through and make an adjustment. They say when A and B are controlled, C prime is significantly reduced with the strongest evidence for mediation occurring when C prime is equal to 0. Okay. Anybody an idea why did we go from, hey, C prime has to be 0 to, well, it doesn't have to be 0. Great if it's 0, but what we want to do is see at least a reduction in C to C prime.
There would be other factors that might impact the relationship or not.
Exactly, right? Or certain things, right? Like if I'm talking about engineering and physics and things like that, maybe there's like one thing that causes these things to be related to one another, right? But in behavioral sciences, there's rarely one thing that's going to be fully deterministic of that relation, right? And so what we can get into a situation is where we've got multiple things that might contribute to the X being related to Y, okay? And so what might happen, because we can't account for probably all things in a single model, what we might find is even after we account for something that really does influence this relation, we still get a path, we still get evidence of a residual association between X and Y, even once we've accounted for this, right? That's probably just saying that there are other things that contribute to this association that we haven't measured. And so X and Y are so, or maybe X causes Y directly. Like that's a possibility. Maybe X causes Y directly, and then there's something else that contributes and goes through and pulls in. And so what Barron and Kenny are saying is that, boy, maybe it's too stringent to say that you can't have a path there, but we've got to see at least some reduction, right? Because if I go through and I get this and this, but this is still the same strength as it was before, that's not super strong evidence for this being something causally going on in there, right? So what we did is we went through and backtracked that, because this is probably not a plausible situation for a lot of the stuff that we do in psychological science. So what we see is we want to see a reduction in C to C. Kind of understand kind of why we're the Dale, you have a question?
Yeah. Yes, I don't know how to articulate it. So if if X does have a direct effect on Y, but then we also find an indirect effect, when we take away the indirect effect, what do you mean we want to see a reduction?
Yeah.
So gets more significant or less significant once we take away the mediator?
The strength of the association, the coefficient goes down, not the
Okay,
yeah.
okay.
So let's say I've got a medium-sized effect between X and Y, just X and Y. But I go through and I count for this mediator, now I've got to still have an effect, it's a smaller effect, because essentially what I've done is I've pulled out any of that variability between covariance between X and Y that's attributable on my mediator. So I'm pulling that out. So what I'm left with is a smaller association. Okay. Good question. All right. So, okay. So this is our causal steps approach. And this is our classic approach that we've used until so relatively recently, right? But there's some underlying assumptions with our causal model. We're assuming that X causes Y and not the other way around, okay? Allison, in cross-sectional data, is there any way to determine whether X causes Y? No. There sure isn't, right? And so we have to have a strong conceptual argument if we're not using longitudinal data, that yes, X impacts causes Y and not the opposite way around. Because I can say, like, I don't know, I can come up with a reasonable argument that maybe Y causes X. All this stuff starts to fall apart. Okay, so we're assuming that X causes Y, not the other way around. We're assuming that the mediator precedes Y in time and that the mediator is a plausible agent of Y. Okay, so classic steps, a causal steps approach is in nature, in theory, a longitudinal analysis, right? Because we're saying that this mediator is something that happened or we measured before we measured Y. Okay, again, we're trying to set up some argument for directionality here, right? If the assumption is that if mediator was measured before Y, then Y can't go back in time and cause the mediator, although there's interesting arguments about some of this stuff, right? So we're seeing that our mediator should precede Y in time temporally, and that the mediator has to be some plausible agent of Y. It can't just be some random ass variable. There's got to be some conceptual reason to make an argument that says, yes, this is a thing that could drive variability in our outcome. And then finally, we're assuming that the relation of X and Y is not the product of some unmeasured construct or process, right? So we're saying with our causal steps that we've got everything in that model that needs to be in that model, right? In order to make reasonable, logical, causal inferences, right? Because if there's other things that I haven't included, then I've got associations in there that are due to other things. But what I'm going to do is I'm going to interpret my model. I'm going to say it's because of X, when in fact it isn't because of X, it's because of other things. I just didn't measure those things. But the idea between a causal steps approach is trying to lay out arguments that no, with this, we can start to at least infer or at least conclude that at least we have some evidence of sort of this is a causal agent. Cool. So kind of understand the assumptions that this is predicated on. Yeah, Johnny.
So I just want to make sure I'm understanding. So for that last assumption, in your example with like pavement like temperature and then drowning deaths and the mediator possibly being like swimming behavior.
Yeah.
What we're essentially saying is that if we were to run that model, we're saying that swimming behavior accounts for all of the variability.
In Judd and Kenny, in their original thing, swimming behavior is the thing that drives this, right? And so once I account for swimming behavior, C prime is equal to 0, right?
Okay.
Now, what is going on in sort of this is not the product of some other measured or construct or process. They're saying that, like, boy, we may have some residual stuff in there. What this starts to get into is like some econometrics type. Did anybody take economics as a college level course? Okay. Olivia, you as well?
No,
Oh, okay, sorry.
more than have not.
What's up?
I was just following along.
Okay. Misinterpretation of cues. But so if we get into econometrics, right? The idea is that with our statistical analyses, we're actually modeling causal behaviors, causal stuff. Now, I can't set up an economy and just like follow it and like watch what's going on. So it's hard to do experiments if I'm looking at like stock markets and things like that, right? So going through and saying like, hey, everything's in the model that needs to be in the model, right? Now, so this is just saying that there's not clear, obvious other explanations in there that are driving things other than what we've gotten sort of accounted for here, right? And this starts to become important in psychological science because our constructs all overlap with one another and they're all kind of stacked on top of one another. And so sometimes I can be like, oh, like this is the thing that's driving this. Like, well, maybe, but you've measured it all through a questionnaire measure. And maybe it's not this specific construct that you like. Maybe it's just negative affect just because people aren't feeling, there's nothing special about the thing that you pulled in. It's just, if I used any other measure of a different construct that had the same level of saturation of negative affectivity, I'd get the same thing, right? That's where sort of this stuff is going, right? We're saying, hey, what's going on is a direct measure of the construct that you're actually trying to measure and not just neuroticism, things like that. Okay. So what we're trying to do is set up a scenario where we can infer something about, yes, this is a plausible mechanism. We're trying to get a causality. Yeah,
If we go back to the hot pavement drowning.
Yeah.
Scenario or whatever.
Yeah.
If our proposed mediator was like school's out for summer, that would in theory not maybe account for the entire mediation, but our theoretical model might only include that.
yeah, and that's where it starts to become important, right? Because you say, look at this, I've got evidence of an indirect effect, I got a mediation effect, right? But maybe me as a reviewer, like, well, yeah, but school being out is not like school being out in Northern Alaska probably is not sort of relevant to this, right? Like what's actually going on is, yeah, you captured it, but again, sort of the school being out is just a proxy for temperature, right? And temperature is what's really driving this, because when it's warm outside, people are more likely and stuff, right? And so this is where it starts to get into a conceptual issue. Like, did you actually capture it, or is the thing that you've measured here just a proxy for something else, right? Kind of squared away on these. All right, cool. So with the introduction of Baron Kenny's work, we opened the door for cases of partial mediation. Okay. Again, given that for the types of things that we work with, there's very rarely, if ever, going to be like one cause. Partial mediation says, hey, here I've got evidence of this thing as accounting for part of this relation, maybe not all of it. Okay. And so this is an important concept to be thinking about as you think about your own work or evaluating work in this area. Things that can start to contribute to this idea of partial mediation, why we might not find that C prime goes completely to zero, why C prime might kind of hang out and continue to have a residual association between X and Y, even once we account for this mediator, okay? We talked about this, X can have both a direct effect on Y and an indirect through the mediator. Part of X, there's something about X that directly causes Y, but then also there's other factor, this mediator that's going through and kind of picking up some other stuff that's increasing this association, right? X and Y are related 25%, but when we go through and add in this mediator, it's 50% because it's an additive type of a situation going on. Okay. We can also have a situation where the relation between X and Y is mediated by several processing constructs, but only a subset are included in the model, right? This is one of these things where something like process starts to become really nice, because we can start to include in there multiple mediators, and it'll do that pretty easily. It's hard to do that with partial or with the causal steps approach. You can do it, it just takes some work to go through and do some stuff, right? And so what we would say then is that, yeah, we've got, this accounts for some of the relation, but there are other things in the model, right? Now, like we had talked about before, technically this is a specification error. Because if we have a properly specified model, we're saying everything that needs to be in there is in there, and things that aren't don't need to be in there, right? So if I had a situation where I have, like, say, 3 mediators, right? There are 3 mechanisms, and I've only accounted for 1, right? But my mediators are correlated with one another. What can happen is the mediator that I do have in there is picking up some of the residual stuff that is actually attributable to the other 2 things that aren't my model, but I don't know that. So what I might find is this indirect association between X and Y through my mediator looks stronger than it is if I would have properly specified my model. Yeah, it's a mediator, but it's not as strong as it would be if I had mediator 2 and mediator 3 in there, because mediator 2 and 3 are correlated with mediator 1. And so there's just some residual stuff that's kind of picked up that's being overestimated with this, right? So again, one of those things we need to be careful of. So again, this can happen, but technically this is a specification error. If something should be in there, we should probably have it in there. Okay. At least if we're trying to interpret these coefficients as this is representative of true population effect going through, right? When in fact it might actually not be. Indirect effect of X on Y through the mediator is not constant for all members of the population. Okay. What we might find is that, yeah, we've got an indirect effect of X on Y through my mediator, right? But it doesn't account, they still have a residual effect. What can happen is that this indirect path is stronger for some segments of the population than others, right? And so there's, for a subset of my population, yeah, this serves as a mediator, but not for everybody. Sometimes it doesn't, right? And so what I could do is I could still find a path here that's picking up for, let's say, the 20% of my population where this doesn't act as a mediator. And so they're just, that is still there. And for 80%, yeah, this is strong, but we've still got a residual effect here. What we're looking at here is what we would talk about as a conditional indirect effect, or more classically as a moderated mediation effect. There's some now fourth variable that's changing the strength of one of those associations. So that indirect effect is less strong, or changes depending on what subset of the population we're talking about. Okay. So we can go through, and this starts to turn into some pretty cool models, so long as we can justify and explain exactly what is going on and sort of why we're expecting this thing to happen. Okay. And finally, measurement error in your mediator can result in an underestimation of its relation with both X and Y. If I've got a lot of error variance in that, A is going to not be so strong as it would otherwise be. B is not going to be as strong as it otherwise would be. So that indirect effect is weaker than it would be if I had a good measure. And so what's going to happen is I have just a residual effect of X on Y, just because I have a poor measure of the mediator here. Okay. So again, lots of improvement from the original Judd and Kenny approach to the Barron Kenny, to go through and acknowledge there are lots of different reasons why I might continue to have a residual association, why C to C prime might not just go completely to zero. This makes some sense? Okay. All right. So how do we go through and test this? Good news, testing this with causal steps is pretty easy. Okay. First thing we want to do, we want to regress Y onto X to establish an effect that can be mediated, right? So we're going to go through step one model, just regress Y onto X. And this is your estimate of path C. This is just saying, is there an association B to be had? With this simple model, what's another way I could go through and establish this? What's that?
Just do a correlation.
Yeah, exactly right. It's just a correlation. There's nothing fancy going on with this. Okay. Now, in order for following up with sort of the stuff that we'll do later on, you want to have this just so you have that effect measured. But really, we're just talking about our X and Y correlated with one another. Okay. Step two, what we're going to do is we're going to regress our mediator onto X to demonstrate an association between those two things. Again, easy peasy, regress that onto that. We're just testing path A. Okay. So step one, we estimate path C. Step two, we estimate path A. And again, same thing. This is just essentially a correlation in our most simple mediation model. We're just demonstrating an association here. The idea being that if our X variable isn't related to our mediator, it's kind of make it harder to argue that this serves as a plausible mechanism, right? And then finally, what we're going to do is we're going to regress Y onto both X and my mediator to establish a unique association between the outcome and the mediator, my C path, or my B path, above and beyond the residual effect of X. Okay, so I'm saying that, hey, if I account for X, do I still get an effect of my mediator on my outcome? Okay. What we don't want to do is just look at individually the mediator on my Y, because my conceptual model is sort of saying that this is both a combined function of both of these things. Okay. And then if I don't include X, I don't get that C prime value anyway. And so that kind of the whole thing falls apart. Okay. So what I'm going to do here is I'm going to get in this final step, I'm going to get an estimate for path B, and then I'm also going to get C prime out of that, because I'm going to be looking at the residual relation of X on the Y.
You saw me. So when you say regress Y on X and the mediator,
Yeah.
you mean basically that Y would be your dependent variable and you just put X and the mediator in the model, that's
That's
it.
your predictors, yep,
Okay.
that's it. Okay. And then last thing we gotta do once we've gone through and done this is determine whether or not our mediator completely mediates the relation of X and Y through our test of C prime, okay? In this last model, we're gonna get the residual relation between X and Y, because we've got mediator and X as a predictor. You should have an effect on my mediator, and then I'm gonna go through and take a look at C prime. If C prime is, if I don't have evidence for a residual effect, then according to causal steps, I can claim full mediation, right? But if I have a non-zero C prime, if I still have evidence for an effect there, even after I account for the mediator, it's just saying maybe I have partial mediation. People getting the concept here? Okay. So then now we get into a tricky situation here with partial mediation, because Judd and Kenny is saying, or Barron and Kenny are saying, what we need to see is a significant reduction in C to C prime. Well, what constitutes a significant reduction, right? And here's where we get into some simple math that's kind of cool. From a classic approach, the way we would classically test mediation was this specific test of the difference between C and C prime. C is our path just with X and Y bivariate. C prime is our path controlling for my mediator, right? And from a classic standpoint, what we're doing is we're saying, can I claim partial mediation is a specific test of the reduction in that coefficient in the bivariate case to the one where you've got that other model in there, right? Now, mathematically, the thing that's very, very beneficial to remember is that this indirect effect of X on Y through my mediator is given as a product of paths A and B, okay? So if I take path A and multiply it by path B, that gives me my indirect effect. And consequently, within this A to B, the product of AB is mathematically equivalent to C minus C prime, okay? And so what we're saying here within this model, within this series of analyses, there's a couple of different ways that we can go through and talk about mediation. We can talk about, in the old school way we would talk about mediation is evidence of this reduction from C to C prime. And that's a fine way to go through and talk about things. I have an association, but that association now is reduced as a consequence of accounting for my mediator, okay? Problem is that's kind of an inflexible way to go through and think about things, particularly if I start to elaborate and I start to add in more mediators and stuff like that. Well, I might get C to C prime, it's smaller, but like I've got a bunch of stuff in the model, right? And so the way to think about this that's a better way is to think about not a reduction of C to C prime, but as a test of your indirect effect, right? Does the product of path A and path B, is that some non-zero value? Mathematically, it doesn't matter. C minus C prime is mathematically identical. It's the same thing as A times B. So you're talking about the same thing. And so consequentially, with our simple, that's the second time I've used that word in, I don't know. I just like, I don't know if I've said consequentially. I don't know, and I just did it twice within 5 minutes, so. I'm actually a chat bot. If I go through and think about trying to account for everything that's going on, the total effect of X on Y is equal to the sum of all direct and indirect pathways. So if I take my AB path and add C prime, this is going to be mathematically equivalent to C. Okay. So it's a nice, easy, simple set of equations. If I'm sort of understanding what's happening, I can kind of pull all this together. All right. So in the classic sense, in the causal steps approach, what we need to do is have some test of whether or not C minus C prime is some sort of significant reduction. Okay. And if we want to go through and test whether null hypotheses, whether C minus C prime is equal to 0, we have to get a standard deviate or standard error for that mediated effect. Someone tell me what is a standard error? become important. So understand our standard error is a standard deviation of a sampling distribution, right? Or the extent to which we can expect some coefficient to jump around across replications. Okay, so what we need, remember that we always need a standard error if we want an inference test. And so what we need to do is we need to go through and be able to derive one of these for C minus C prime. And so what we've got is something known as a Sabel test or a Sabel formula that approximates, it's not exactly, but it approximates a standard error for this indirect path of AB, or consequentially C minus C prime is the same thing. And so here we're taking the square of your coefficient B, multiplying it by the square of your standard error for A, plus the square of your coefficient for A, times the square of the standard deviation for path B, plus the square of the standard deviation for A, square standard deviation for B. Run that out and take that standard error divided by coefficient for AB, gives us a z-test that we just say, is it bigger than 1.6 or 1.96? Just run that on a z-test there. Later paper, McCune and Dwyer have gone through and signed this, suggests quantifying the magnitude of mediation as a percentage of the total effect. And this is pretty cool, right? If we say, if we take the relation between X and Y as the total effect that we're trying to mediate, if we take A times B divided by A times B plus C, which is the total effect, we get of the total effect, 30% of the total effect is mediated through sort of this path, or 80% is mediated through this path. Kind of a nice kind of intuitive way to go through and describe what's happening here. Okay. So mathematically, what we want to remember is we've got path A, path B, C, and C prime, right? And what we're doing with this simple mediation model is we're saying, of this total relation, what's being accounted for by the mediator, right? If I'm thinking about the total relation, which is marked by C, C divided off into its components parts is the sum of A times B plus whatever is left over in terms of C prime. In that? All right. So conceptual example. We're not going to fool around with SPSS because you already know how to run regression models. It's pretty straightforward. Okay. What we're looking at is we're saying, do attitudes towards support utilization account for the relation between PTSD and social support? Okay. So in my area, we know that PTSD is related to force reductions in social support. That's been shown time and time and time again, right? So we're tired of that. That's not interesting anymore. What we might be interested in is why exactly do we see this association? Okay. And so here what we're saying is like maybe the relation between PTSD and lower levels of social support is because people are less willing to utilize support networks. I can have all the support networks available to me. If I don't engage with them, they're useless because I'm not utilizing them, right? There's a lot of reasons if we get into trauma stuff, why people might be hesitant to reach out and receive help from other people, right? So what we're going to look at is see whether or not the support utilization variable accounts for, at least in part, the relation between PTSD and reduction in social support, okay? So my variables, I've got a support variable, continuous variable, range 0 to 7. Higher scores indicate higher levels of perceived support. A utilization variable, continuous indicator of attitudes towards support utilization. Higher scores, more negative perceptions of the utility of using support systems. You can't trust other people. You got to go it on your own. People will take advantage if you get an opportunity. You can't be vulnerable in front of other people. Some of that type of stuff. And then PTSD is our continuous PTSD. So in SPSS, going to step through our causal steps. Okay. Step 1, we're just going to regress PTSD onto, perceived support onto PTSD. Okay. And Jalen, do we have evidence for step 1? Do we have evidence for this C path here? Yep. I have a coefficient of negative 0.03, which doesn't seem all that big, right? But we've got scales that are sort of pretty big here, right? And so if I go through, look at my standardized coefficient, about negative 0.3. So that's, makes some sense. That's a decent sized effect. This is a medium effect, right? Very small p-value here, right? And then if I look at my other correlations here, my zero, my part, and my partial correlation are all identical. Why is that? Do you have any idea?
Because we're not controlling for any other variables.
There's nothing else in the model, right? Here, there's nothing to partial out of, right? We've just got my zero order correlation, which is just the association between X and Y, which is the same thing as my partial, which is because there's nothing, because we're not pulling anything else out, right? Also, if we take a look at my zero order correlation and look at my standardized coefficient, that's identical, right? So it's all part and parcel, part of the same stuff here, okay? Right, people see kind of what we did there was step one. We established a relation to mediate. All right, step two, what we want to do is we want to, and so here we've got path C. Now we want to go through and establish that my mediator is associated with my X, right? Because if I'm going to say, hey, this thing is a mechanism, I should probably be able to demonstrate an association between my predictor and my mediator here, right? So we go through and we do that, and so we regress support utilization onto PTSD. Same situation. Daniela, do we have evidence for an effect here?
Yes.
Yep, we sure do, right? And same thing, here we've got my unstandardized coefficient, my standardized coefficient, evidence for an effect, and then sort of these are all the same, because again, it's just a bivariate regression. And so we're good to go here. Okay. So again, this is going to be my A path. Then the last step, we're just going to regress perceived support onto both PTSD and support utilization. Okay. And we go through here, regress sort of Y onto both of my other two variables here, and I get an effect for PTSD symptoms. Excuse me, let's start with support utilization. This is my B path, okay? Is my mediator related with my outcome? Okay. Is mediator related to my outcome?
Yeah, but.
Yep.
Yeah.
Yes.
Stop at the yes.
Yeah, stop at the yes. Yes, we do get evidence for this B path, right? He is related with my outcome, okay? And saying that, yep, it looks like even when I control for PTSD, support utilization is associated with reductions in perceived support, okay? And now my zero, my part, my partial, those are all different because now I'm partial things out, right? But then I've got a C prime path, okay? Johnny, what's C prime giving me?
When you pull out the variability of the mediator.
Yeah. And do I have evidence for C prime? No, that's gone from something that was sort of pretty good effect down to something that is now no longer registering as we have evidence for anything here, right? So what we would say in this situation, if we were using causal models or causal steps approach, we would say we have evidence of full mediation, right? Once I account for support utilization, PTSD is no longer associated with reductions in social support, you know, and so within the context of this approach, we would say that, yeah, it looks like sort of people's willingness to utilize support systems available to them may account for the total, all the variability in this association with PTSD and reductions in perceived support. Yeah.
So if that's step two, if there was not evidence for an effect, you would essentially stop there, but would you be able to report like that means that there was not evidence of a mediation effect?
Yeah, and this starts to get into a tricky thing.
Okay.
One of the drawbacks, but yes, from a causal steps approach, we would say, well, we don't have evidence for an effect there. So it's hard to make an argument for this is a mediator if my mediator is not related to my outcome. I mean, there are cases that we will go through and talk about like where that will come up, but it conceptually starts to become a more difficult model to argue. Other questions? Good. Okay. All right. So we did not So technically here, we don't need to from a classic approach, we would say that, boy, we don't need to go through and run a Sobel test because we went from a C path to C prime that now C prime is no longer there. Now, what starts to happen, you can start to fool around. Let's say, Gabe, that I had a situation where I had evidence for an effect to start with, right? But my p-value here was, say, 0.045. And then I go through and I include this and I go down here and now I don't have it, or I'm sort of not meeting criteria for evidence, but it's like my p-value is 0.055. Would you be very convinced about sort of possible mediation there just based on that? Probably not, right? I took something that was just like right on the right side of the line and then added in another variable, and now I'm just like on the wrong side of the line. So there's a situation where you'd be like, yeah, but like this is not this situation because this is very clearly something going on there and then it all goes away, right? But there are a lot of situations where I might say like, yeah, I kind of got a small effect that just kind of tips over and then I threw another variable in and now it sort of goes away, right? And anytime we throw another variable, particularly a correlated variable into a model, what should we expect happen to the impact of other effects? Kind of going down because we're just kind of chipping away at it, right? So the question could be like, have we seen a significant reduction in C to C prime, or is it, or alternatively AB, or is what we're talking about just like sort of error variance or sort of error fluctuations just jumping down, right? So what we could do with this outcome or this model here is we can go through and actually run our Sobel tests to see if we have evidence here. So for coefficients, and sort of make sure when you're looking at this to go back through and make sure you see where these are coming from. This is the coefficient for my A path with the standard error, coefficient for my B path, standard error, okay? Pretty simple formula. We're just going through B path squared plus standard error for A plus A squared plus standard times square standard or standard error for B, and then standard error for A squared, standard error B squared, pulling this together. One thing I will say, now that you've all gotten a decent amount of practice in setting something up like this up in Excel, it's actually kind of nice. Sometimes these standard errors can get pretty small. You can get a decimal that starts to crank out pretty high. So you want to be careful with your rounding error. A nice way to go through and do this stuff. But if we go through, crank this out, we get a standard error equal to 0.003. And then all we need to do is we need to just take AB divided by standard error that we just cranked out here. We take 0.251 times 0.084, multiply those, divided by 0.003, we get a z-test, right? We can plug in that into our p-value calculator or sort of an Excel sheet to get an actual p-value. Do we need a p-value for that? No, that's very clearly going to be something that's a large C value, right? And then we calculate SPFB. Okay. So what we would say here is that yes, so this is a specific test using our causal steps approach of that indirect path of AB, right? So if we're saying X, Y. Saying, do we have evidence of this indirect effect, right? And then here we've got this is C and C prime, right? We can talk about this as an indirect effect of AB, talking about this as the indirect effect of PTSD on reductions in social support through support utilization, which is a nice way to talk about this, right? From a classic approach, we would talk about this as C minus C prime, right? But these two things are identical. They're the same thing, right? And so when we're talking about this, this is probably conceptually a better way to sort of think about this and conceptualize this. This works for simple mediation models and it's fine. But where we progress to at this point, it starts to become a little bit more complex as we get into like SEMs and path models and things like that. All of this holds, right? I can have something that's. That's a more complicated model, right? It's hard to talk about this in terms of C minus C prime paths, but I can talk about direct effects through any of this using this same framework. Okay, and this is with a process model, this is kind of what they're talking about is indirect effects as opposed to reductions in C minus C prime. People comfortable with this? Okay, and again, the models are super easy. You're just running 3 simple regression models. And then if you want to run a Sobel, then you just plug things and throw it in that equation. Multiply your indirect or divide your indirect effect by your standard error. Boom. Okay. So much more simple and straightforward than the moderation stuff that you're working on right now, which is huge victory, right? That's nice. Okay. Questions? All right, cool. So walk through causal steps. People say, well, why even talk about causal steps? Causal steps isn't the thing that we do anymore. Absolutely right. But it's important to know why we don't do it because that starts to become important in thinking about how we go through and start interpreting stuff. I've got process model, 48 or something like that. How do I understand sort of how to go through and interpret some of this stuff? Okay. And a number of different reasons why this has been criticized. One, it's called causal steps, and in theory, sure, but there's some problems with this, right? Has anybody worked in a lab with someone who, and so maybe some more experimental folks, where people just like really conservative about sort of this what circumstances under which we can talk about causal effects? Yeah. And so probably as we're going through talking about some of this, ringing alarm bells back, well, you can't establish, you can't say causality with that because it's not, and it's absolutely right. And that's what's going on with this stuff, right? So some people, even within the confines of like strict experimental, controlled experimental stuff, like any talk about causality gets you strung up, right? And so people immediately said, like, well, you calling this causal effects, you can't call this causal effects because you can't establish causality, right? People will say experimental design is providing a more rigorous test of mediational processes, right? Here we're going to go through and we're going to randomize to control for external factors. And so if I truly have evidence of mediation, this manipulation should be the one thing that accounts for anything going on here. And anything else there, it's a failed experiment. And even within that, there are other things that we didn't measure that we probably should have in there. Like you can't just like in a series of 3 simple regression models start making claims for causality, right? And very strong arguments for mediation being something that we cannot establish and shouldn't even talk about within the context of a correlation design. Okay, if I have longitudinal data, right? If I measure X today and my mediator a week from now, and then my outcome a week from that, that at least gives us some temporal precedence in terms of things going on. But even that, people like there's so many other types of things going on that we cannot conclude causality from this. Okay. And this is one of these things. If your mediation models are kind of simple to put together and they're easy to kind of think about, more so than moderation models, but you've got to, particularly if you're using anytime, but particularly if you're using correlational data, cross-sectional data, you have to be very strong in terms of your arguments for why have I set this model up the way that I have. A lot of times when I review papers, you see a mediation analysis like this. If I could go through and take 2 or 3 variables, put them in a bag and mix them up and just like randomly assign them to other places, and the model I get makes just as much sense as the other one, you're not on good footing, right? Particularly within the context of this. Now, there are some people who will say, you'll run into reviewer spec, you cannot run these analyses certainly, in the absence, like if you've got longitudinal analysis, data, fine, but certainly not with cross-sectional data. I think that's too stringent. And Hayes also thinks this is too stringent, but I think there is a level of burden of proof to tell me why this path versus something else that I can just flip around, right? This is particularly an issue for clinical folks because I've got like 3 different distress variables that I put in. Even with this example we went through, why not social support producing PTSD, right? That's typically how we think about this, right? So I actually sort of have a paper out sort of with this, sort of, but had to lay out a very strong argument sort of based on other stuff for why we're setting this model up the way that we did. So needing to think very carefully about how we're going through and setting these up from a conceptual standpoint. And certainly just because I'm using, this is the other thing too, like SEM will sometimes be, have anybody ever heard of SEM, structural equation modeling, heard of it as causal modeling? It's something that comes up. It's sort of one of the many names that has like, oh, well, we use causal models to go through and establish this big. Well, there's nothing causal about anything we did, right? You can make a conceptual argument for why this is a plausible model, but you need to make sure that you lay that out with supporting data, things like that. Other thing too that starts to get into some interesting discussion is people say, well, this causal effects, this causal steps approach requires a significant relation between X and Y, right? But from a mathematical and a conceptual standpoint, this can start to be problematic. Certainly, for sure, if I have a baseline association between X and Y, it makes my life a hell of a lot easier. There are circumstances where even if I have evidence or I have a situation where I could make arguments for mediation, I might not find that initial association, okay? If X and Y are related to one another, if I have cross-sectional data, those 2 things should be related to one another, right? But as that causal process starts to become more distant, the relations can start to be attenuated due to a lot of different things, right? So if I measure goals, motivations, intent today, and then measure your behavior 6 months from now, or maybe even next year, or maybe even longer, there's lots of reasons why I might not find an association between the thing I measured today and things going on out later on. That doesn't mean that those 2 things aren't related. They've just been separated by time and space. And so there's, in that temporal distance, there's time for other stuff and constructs to start coming in and playing a role in stuff. We've got other competing processes that can, yeah, it came in, but we've got something working in the opposite direction can start to counteract that. And then we've just got random error. Like the person I am today is probably not going to be exactly the person I am 2 years from now in terms of how I approach measurements and things along those lines. Maybe I didn't have good at measurements to start with. And so all of these things, particularly if I'm measuring something distally, I can start out and not have an association between X and Y. Now, as Abby was saying, if I don't have an association between X and Y, causal steps, we put on the brakes, there's nothing to talk about because there's no relation to mediate, right? But conceptually, there are things that can go through and start to make that more difficult to detect. Also, just thinking about power, right? If I've got 50 people and I've got a correlation of 0.2 between the thing I measure today and the thing I measure 2 years from now, but I only got 50 people because it's hard to keep that many people in the study. But I've got a correlation or an association of 0.2. My p-value is not there. I'm like, well, I guess there's no association there. Like, I don't know. If I had twice as many people, would that correlation of 0.2 come up as statistically significant? Yeah, right. So then you got a power issue to deal with, right? So lots of reasons why we might not see that baseline effect. Now, if you measure them right next to one another in a sort of cross-sectional like questionnaire packet, if they're not related, you're going to have a hard time making an argument for this. But for longitudinal data, you start to have problems, right? Or there can be certain things that start to come up and sort of degrade that association. And in some cases, power to detect these causal processes might be much better than the power to detect your direct effects, okay? So think about a case where paths A and B are consistent with medium effects, right? So A, B, medium effects, let's say 0.3, right? Sample of 80, that gives me power to independently, if I got 80 people, I'm powered to detect that leg. If I got 80 people, I'm powered to detect that leg, because I'm both looking at medium effects, okay? But if we think about, if we've got complete mediation, right? If this is the only thing that's going on, my total effect is gonna be this product of AB, and if I take 0.3 times 0.3, that's saying the bivariate association here is gonna be 0.9, and I need about 1,000 people to detect that, right? So again, it's one of these things, in cases of full mediation, I can have an effect here and I can have an effect here and no problem detecting that. But if this is the only thing that's going on and driving this association, when I just look at correlation between X and Y, the correlation I'm gonna be looking at is 0.09, right? Now, that doesn't mean that they're not related, they're very, very weakly related. And maybe what I'm interested in is more about this process that's going through, right? Particularly if we're thinking about, bigger, like, stuff that's sort of going on, sort of like policy types of stuff. Like, hey, I did this intervention, or so we did this thing to try and impact, underserved groups here, and we're looking at the impact on something 10 years down the road. Well, I'm not finding an association there, right? So like, oh, well, it didn't work, no good, right? Maybe that's not the case. Maybe there's a lot of stuff going on there that's causing sort of impacts. It's just happened so far out. There's lots of other things coming in. If this is the thing that's driving all of it, like the baseline relation is pretty weak to begin with, right? So there's just lots of different reasons why having this requirement for needing to have a evidence for an associative exon Y to begin with can start to become problematic for conceptual reasons. Okay. So again, your life is much easier if they are. That's a much easier paper to write. But just because they're not, doesn't mean all is lost. There are other things that can go through. If you can make credible arguments that some of these other things that can happen, maybe you say like, well, we didn't find an association between X and Y. These are the reasons we think that's happening. And so we've elected to continue on regardless. All right, cool. Let's take a break there and pop back in 3:40, and we'll finish up with mediation stuff.
I have to ask you a question.
Yes.
Did you want to zoom this on the board?
What's up?
Did you want to zoom the camera?
Oh, yes, I will do that. Thank you, Mandy.
Is it 20 years older than me?
I am 20 years older than you.
Wow.
That was weird.
What is your birthday?
Yes.
At least it's not like you're my dad.
Well, that's probably not an unreasonable thing. I used to be young and hip and cool. Those days are gone. It's all right though.
Me too. Now I'm turning 28 on Saturday. It's all out the window.
That's,
Forever young, remember?
okay. Gonna jump back into working through sort of limitations of causal effect stuff here. Oh, now we go through. Did I already start recording this? Okay. So. Any questions about, concerns about this, the requirement of having this operator effect? You okay with this? Okay. Cool. Now mathematically, what we can get, we can also have shenanigans going on. They start to complicate things, okay? Shrug and Bolger in their paper, talk about a suppression effect. And this is different than the suppression effect that, Tabachik and Fidel go through and talk about. But what can happen in rare occasions, you can have a situation where your indirect effect cancels each other out so that you no longer have a direct effect, okay? So let's talk about a situation where we've got coping behaviors, our mediator, and we've got environmental stress and psychological distress. Okay, so we've got stuff going on, stressful environment, right? And so the idea is that coping behavior is going to mediate the relation between environmental stress and just psychological, or we'll call it well-being. Okay. In this situation, we would expect environmental stress and coping to have a positive relationship, right? As stress goes up, I have to engage those coping networks, right? So as my stress stuff goes up, my coping activities increase. So we've got a positive effect of A. And then I would expect coping and psychological distress to hold a negative relationship, right? As my coping resources go up, my distress levels should go down, right? And so as a consequence of this, because we've got a positive path and a negative path, the indirect effect of AB will be negative, okay? But because the total effect of X on Y is your indirect plus your residual left over from your C prime coefficient here, what could happen is if my AB path, which is going to be negative, and then after we account for my mediator here, my coping behavior, still I have some residual association between stress, environmental stress, and well-being that's positive. As stress increases, distress increases, right? If that residual path is about the same magnitude, but in the opposite direction as that indirect path, if I take my indirect path and add in my residual path, I can get something very close to zero. That doesn't mean that X and Y aren't related with one another. It just means the indirect path through coping is about the same size and magnitude, but in an opposite direction as my residual path. And what happens is I get a suppression, I get a masking of that. So if I were to go through and just say, hey, is environmental stress related to well-being? My bivariate correlation is going to be close to zero, right? And probably what I'm going to do is I'm like, oh, cripes, the whole thing is a failure. I didn't define the effect that I'm looking for, even though it seems like stress should be related to sort of our well-being, right? So again, talking about this situation where I can have a mediator that's off working in the opposite direction, similar magnitude, it's just opposite direction as this, where we can go through and these two things come together and void out this. And so if I'm going through from a causal steps approach and say, oh, you need to have a relation between X and Y to start with. In this situation, I'm like, well, there's no relation between X and Y, so no reason to step forward. Although I very strongly believe that there should be an effect here, what you can happen is some cases of suppression where stuff starts to go backward. This probably is pretty rare, but it's certainly something that can feasibly happen. And so again, a good reason to start thinking about when you're running analyses, thinking about conceptually what's happening with things and not just relying on p-values to determine presence and absence of things, okay? In this situation, if you can find an effect, what's going on here, right? And sort of kind of trying to go through it and figure some stuff out. Okay. So again, suppressor effects here different than suppressor effects talked about elsewhere. Just make sure you keep those things straight with one another. So for a priori effects, recommendations here in terms of actually running these analyses. If I'm looking at things that are sort of measured at the same time or very close in time, I should expect X to be related to Y, right? It's just useful. It makes it easier to talk about sort of a mediation when I have an actual relation, an association to mediate, right? But we could maybe start to relax this situation where I'm using distal, looking at distal mediation processes, like a longitudinal design, right? So let's say, Kate, you're looking at something where you're looking at autism diagnoses early on and then sort of outcomes in elementary school, like down the road or something like that. That's a lot of time. There's a lot of stuff that can come in there. Hopefully you see the space effect, but there may be situations where you could make an argument that we're gonna relax that initial assumption, okay? we get subtle effects of X on Y, right? Complete mediation with modest samples, right? I might find that, going back to that situation where I've got power to detect my A path and I got power to detect my B path. But if I got complete mediation, my C path is going to be the product of those two, which can be quite small. So a situation where you might be able to argue something like that, and then your suppressor effects, if there's something going on there. Now, this would be a hard thing to argue. We'd have to kind of lay things out to say, hey, what's going on is I still ran the whole model where I found my AB path is about the same magnitude in the opposite direction as my residual C. So, and it might be hard to figure out that that's the case unless you just, for the hey ho heck of it, went through and ran your model anyway and then found that out. But that could be a strong argument for, yeah, I think probably what we've got here is mediation. It's just we've got some suppressor effects going on. All right. So some conceptual, so people understand conceptual mathematical issues with requiring that baseline model. Again, 90% of the time you ought to find that because it's just going to make your life easier. But if you're not, it's not the end of the world. There are some things you probably go through and check. Other thing that goes on with cognitive or the causal steps approach, and this is kind of one of the classics of a statistical thing that people have focused on, is that our classic approach for testing the significance of the mediated effect, the standard errors are not actually perfect. Standard errors are an approximation, okay? And because of that, our test of that mediation is not entirely precise using the Sobel test, okay? And so what we know is that the sampling distribution of AB is non-normal, okay? The coefficient for AB path here, my indirect effect, if I go through and plot out the sampling distribution of AB, it's not a normal curve, it's skewed, okay? A positive indirect effect is going to have a positive skew, negative indirect effect is going to have a negative skew. Problem is standard errors derived from Sobel and some of the other test variations on this. It assumes a normal distribution, right? That's derived, making the assumption that the sampling distribution of AB is going to be normal, but it's not, and we know it's not. And so as a consequence, the standard error that we're using is not precise. And if our standard error isn't precise, then our test isn't precise. And so we get into some kind of gray area, particularly if we're right around that sort of 0.05 area. Okay. And so what we find is that when we use that Sobel test, they tend to be underpowered and inflated, resulting in type 2 error. We don't detect evidence of that indirect effect as frequently as we should, right? And we're going to see this attenuated power in all cases, except for, unless I have very large samples or very large effect sizes, I'm probably going to have some bias with the Sobel test, okay? And oftentimes the stuff that we're doing in psychological science, we're not dealing with large samples, and we're also not dealing with large effects. And so then this starts to become a problem in type 2 errors and to failing to identify effects that are probably there, but it's more a byproduct of using a biased standard error, right? It's a fine approximation and it's probably going to be okay, but it's not perfect. Okay. We've got variants on Sobel, but sort of remain limited. The papers that I've assigned to you on this, they go through and talk about different methods and things along those lines and what they've found with some of that. Okay. We also see that the confidence intervals for AB derived from the standard error continue to perform poorly, which is what we would expect if the standard error is not right. Confidence bounds aren't precise, so we get problems with the actual calculation of the test. Okay, so people see why Sobel is just an approximation and not a precise estimate of the standard error for AB. Okay, so what we have is a solution, and this is currently best practice. Some variation on this is bootstrapping. Okay, bootstrapping is a procedure where we're going to go through and we're going to generate an empirical distribution of some parameter, right? We have some parameter and we don't know precisely what the distribution is. And in order to have a statistical test, we need to know what the distribution is so we can actually derive that standard error, right? But with bootstrapping, what we do is we say, okay, we don't know mathematically or theoretically what the precise distribution should be, but we can go through and kind of recreate this, okay? And so what we do is using my observed data, the data that I have, data set, right? Maybe so you've got a data set with 250 people in it, okay? For your bootstrap, that's gonna serve as your population, okay? And so what you're gonna do is you're gonna draw a bootstrap sample of 250 cases from your set of 250 cases drawn with replacement randomly, okay? So what does that mean with replacement?
We're putting it back every time we're
Bring it
going.
back in. So could I have, if Olivia is a person in your set, could Olivia end up in your sample more than once? Yeah, Olivia could end up in your sample a whole bunch of times, right? But what we're gonna do is we're gonna grab a bootstrap sample of equal size to your actual data set. And then what we're gonna do is we're gonna go through and we're gonna estimate your indirect effect for that bootstrap sample. So we're gonna go through, here's my data. I'm gonna pull 250 cases from that data with replacement, and then I'm gonna run my analysis and model out AV, okay? Then I'm gonna do that, steps 1 and 2, I'm gonna do that again for, let's say, 5,000 times, okay? So what I'm gonna end up with is 5,000 estimates of AV based on these 5,000 bootstrap replications. And then what I'm gonna do is I'm gonna use that distribution, that empirical distribution of AB to go through and derive standard errors and confidence intervals for sort of my estimate here, okay? The standard deviation of that sampling distribution is gonna give me an estimate of my population standard error, okay? So I've got, here, let's just do this. So I went through, and this is my bootstrap distribution. I went through 5,000 times, and for each one of those 5,000 samples, I went through and ran my mediation model, and then plotted out what's my indirect effect. My sampling distribution is skewed, right? But what I'm going to do is use that as a proxy for the true population effect, and then I'm going to use this distribution. I'm going to find on the top end. This is going to be skewed. I'm going to take 2.5 points off the top end, 2.5 off the bottom end. That's going to give me my standard error, my cut points, things along those lines for creating my standard errors. And then, so the standard deviation of that sampling distribution is going to be my population standard error. And then because of the skewed distribution, confidence intervals for my indirect effect might be a little bit asymmetrical. Same thing, remember when we talked about calculating confidence bounds around estimates of effect size? We talked about that non-central T distribution is being skewed. And so when you're calculating confidence intervals around effect sizes, sometimes the top end will be a little bit longer than the bottom end. Same thing with this. We know that the sampling distribution for your indirect effects is going to be skewed. And so we would, particularly with small samples. And so we're going to not expect symmetrical confidence bounds around that. Okay. So a lot of like how we actually go through and derive these bootstrapped samples and these confidence bounds, standard errors and things like that. There's some different ways of going through. And if you've gone through and read that paper, you'll hear them talk about accelerated bootstrapped and sort of different versions and things along those lines. Process gives percentile bootstraps. And it's just choosing like sort of different methods for where to go through and cut things off. I think in the latest Hayes documentation, they like percentile bootstraps because they perform pretty well. So that's the one that we'll probably go through and take a look here. But if you've got, here's the thing. This is an argument against Sobel. Because Sobel is not precise, and we definitely should have more anything that's more precise is better than something that's less precise. Now, historically, bootstrapping has not been used because bootstrapping is computationally intensive, right? If it's just me hand cranking out regression models, this is an insurmountable task. But with computing power, this has become very, very quick and easy, right? Now that said, and it sort of gives more accurate estimates of this indirect effect. That said, the differences between your Sobel and your bootstrap stuff are probably going to be pretty minor. You're not going to get too much of a difference with this, okay? But if you've got sort of one of those cases that you're kind of borderline right on the edge, this is a more powerful test and more accurate test, okay? Now with the rollout of like process and things along those lines, if you try and run like a standard Sobel causal models approach, reviewers are probably gonna tell you not to do that. They're probably gonna tell you to use bootstrap procedures because it's just easy to do now. And so probably Sobel stuff is not the way you want to go with things at this point, but know that this is an incremental improvement. It's better. It gives you a more powerful test, but it's not going to completely change the direction of stuff. Like if you were to go through and do a causal steps approach, and you had no evidence of an indirect effect, bootstrapping is not going to help you with that. Okay. All right. Questions about this? Yeah, Johnny.
I'm just having a tough time understanding, why we would use bootstrapping.
Mm-hmm.
And then I'm getting a little bit mixed up with like the width replacement.
Yep, both good questions. So the reason we use bootstrapping to start with, sort of like, remember when we're talking about violations of homogeneity variance. Fundamental assumption, underlying assumption of independent sample t-test is you've got populations have equal variance, right? Problem is if they don't, and I violate that, what I'm doing is I'm going through, and statistical theory would say, like the sampling distribution, my t statistic does follow a t distribution, but it probably doesn't follow the t distribution that it should based on the degrees of freedom, because I've violated that assumption, right? So if I go through and I just use standard procedures to go through and run my test, it's going to be not precise because I'm using the wrong sampling distribution to determine my p-values, right? Same thing with this, right? Sobel test, it makes an assumption of a z distribution, a normal curve, right? Because it's a z test essentially, right? Problem is we know the sampling distribution of your indirect effect, AB, that statistic is not normally distributed, it's skewed, right? And so Sobel is close and it provides a reasonable approximation, but it's not precise, okay? And so if we go through and use that, what tends to happen is that our tests tend to be underpowered. And so with the bootstrap procedure, what we're doing is we're saying, I'm making no assumptions on what the distribution of this statistic looks like. I'm just going to create my own distribution with, say, 5,000 resampling bootstrap samples, and then I'm going to plot out the distribution of AB that I got from all 5,000 of those, and now I'm going to have my own distribution. And what I can do is start using different methods to go through and say, all right, this is the cut point for what we would talk about, the front end, top end, the tail. This would be the bottom end of the tail, and start to get standard errors and confidence bounds from there around my indirect effect. Now with the replacement situation, this is getting back into like old school, like actual sampling techniques, which is always with replacement. Like we don't do that, but like technically any statistical theory is talking about sampling with replacement, right? Here what we're doing is let's say I've got a sample of 50 people, okay? And what I'm going to do is I'm going to create 5,000 bootstrap samples. So I got 50 people. I'm going to pull a sample of 50 from that 50 people I've got, right? But let's say I go through, I pull you out of my set. I'm like, okay, Johnny's person 1, and then throw you back in, right? And I go through and I get Gabe's person 2, okay, throw Gabe back in. And I go through and pull another one, you're back in there. So you're person 3, throw you in there, get you again, you're person 4, right? And so that's maybe that sample. So we go through and get 50 people, but then I do it again, right? Am I going to get the exact same sample that I did the first time? Nope. Every time I'm going to get a slightly different sample that's going to move things around a little bit, right? And so that's where I get with bootstrapping, that's where I get that empirical distribution, okay? And mathematically, this works well because what we can do is we can basically create an empirical distribution of AB and then use that to derive standard errors and confidence bounds, as opposed to assuming that it's normal when we know it's not normal. Is that going to help square some of that away?
I think so, a little bit, yeah.
Mandy, did you have a question?
But you answered it at the end, and
Okay.
you said that our distribution, we're gonna assume that's normal with the bootstrap. I was curious about it.
Yeah. And so
It was-
here, right, what we would do is we would create this empirical distribution, and then we would just take the standard deviation of that empirical distribution, and that's my standard error, okay? Now, normally, if we had a nice normal curve, we could still take the standard deviation of the sampling distribution and have my standard error, but I don't need to because I already know it's normal and I know what the standard deviation should be mathematically and theoretically. Here, we don't know what that is, so we just create something to then go through and work from there. Okay, other questions about bootstrapping procedures and why we use this and why it's beneficial and more accurate or more precise relative to Sobel stuff. Yeah, Johnny.
So when you were talking about on the limitations on standard errors, like slide with that like distribution, you said that we can take the standard deviation of that and that will be your standard error. Is that what
Yes.
you said?
Yeah,
And so then essentially with the bootstrapping procedure, what we're doing is just creating a sampling mean distribution.
yeah.
Okay.
We're using a sampling distribution from the data that we have, right? And so have people been in labs or papers or things like that where they use bootstrapping stuff before techniques? Yeah, it's super common in a lot of different areas. Like, so my brother does wildlife stuff and they bootstrap the hell out of things all the time. And a lot of benefits to bootstrapping. The thing that the one misconception is that, oh, I can get like 7 people and then just use bootstrapping to go through and do it, and that corrects power stuff. Yeah, that's not, that doesn't work, right? And remembering that that our bootstrap, the results of our bootstrap stuff are only going to be as good as our sample. If I got a crazy bias sample, then I'm just going to bootstrap a small crazy bias sample over and over again and get really whack results, right? That don't make any difference or don't make any sense, right? But there are situations where we can go through and use this as a nice tool to be able to reduce some of the biases in certain situations. This is one in psychological sciences where this has come up quite a bit and is a nice way to go through and do things, particularly now that we have systems that will go through and do this for us conveniently and quickly. Yeah.
Is there a recommendation of how small our sample can be to not bias or?
There's a whole literature on bootstrapping stuff. I would say if you have a big enough sample to be running a regression analysis anyway, you're gonna be fine, right? If you don't have enough people to reasonably run a regression model, bootstrapping is not gonna save you. You have people there to start. So
How many people do we?
I don't know. So it depends on all sorts of different things. The size of your effect, the model you're trying to run, you know, lots of different sort of aspects on that. So again, that's another thing, you know, the whole literature on how many people do you need for regression depends, right? It could be something super small or it can be 1,000 people, right? So it all kind of depends. Other questions about bootstrapping stuff? Okay, cool. All right, so what we're gonna do is go through just a real quick demonstration on process. Let me show hands who's used process before, so I know several people have. Okay, pretty slick. There have been different iterations. Before Hayes had this macro out, so you just go through and download and all the documentation was there and that was real good. They've since moved through and kind of changed the models around a little bit. So they want you to buy their book so that you go through and have a sort of copy of all the different sort of types of models that you can go through and run through, which is fine. It's not an unreasonable thing. You can get old levels of process. There was like what we first started with this, it was an indirect macro so that we'd go through and do some stuff. But basically what you're doing in SPSS is you're opening up your file and there's a big old file, like a whole bunch of stuff, right? And it's a billion lines of code. You do not fool around with any of it. You don't change any of it. You don't do anything. You just highlight the whole thing and run it, okay? What that does is that will load the macro up into SPSS. And then what you do, which makes this really nice, and this is why it's really easy to use, is just one line of code where you just go through and identify your model and talk about your different variables. So for simple mediation model, we've got process y equals, this is just your outcome variable, whatever your outcome is, drop that in here for us to support. Put in your X variable, this is your IV, right? This is your main thing right here. We've got PTSD and our data, right? Process, the newest version of process will accept categorical predictors. So Jalen, you got a question on yours. If you just drop that in there, it'll code that automatically. You don't have to dummy code it yourself. My only problem is anytime you do that, like, and I don't know exactly how it's coded things, then I get nervous, right? So you could let process do it, or you could just dummy code it yourself and drop it in there. That would be perfectly fine too. M is gonna be your mediator here. With 341, you can go through and put in a number of mediators in there if you want, right? And then total equals 1. This is just gonna give you in your output your total indirect effects. Model equals 4. This is the way process is set up. They've got a whole bunch of different models. All models with all sorts of different configurations. What you need to do is go through and say, okay, conceptually, this is the model that I want to run because this makes sense. Be very, very selective and have a good reason for selecting the model that you've chosen, and then know how to interpret output, what effects that you should get there, so you can go through and tease this all out. Here for our simple mediation model, it's going to be model 4. So we say model equals 4, and then normal equals 1. I'm just doing this because what it's going to do, if you specify this, it'll just pop out your Sabel test for you for that too. So we're just going to do that with this output, just to kind of see what's going on. But a lot of different options. You put in a bootstrap specification, it'll change the number of bootstrap replications you need. Default is 5,000. That's probably fine. You can crank it up, but it's not. You hit a point of diminishing returns on the iterations. Confidence equals, you can specify that to default is 95% confidence on, but you can change that if you wanted. Normal will just give you Sabel effects if you want that. F size, this is going to give you different effect sizes for indirect effects with bootstrap confidence intervals. Thing is, there's no, at least to my knowledge, not yet like a best metric for indirect effects that kind of is meaningful that you can go through and compare. So this starts to become kind of, there are lots of different options out there, but they all have their flaws. And so this is kind of a developing part of the literature, but process will give those to you if you ask for them. Contrast equals 1. This is going to give you pairwise contrast between indirect effects, right? So this is going to go through and say, if you have multiple indirect effects, right? Let's say I've got a situation where I got, right here, I've got 3 indirect effects, right? I've got indirect effects through M, X1, and X2, right? What I can do is go through and have process give me a specific test on the magnitude of these individuals. Like, is this indirect effect bigger than this one? Is this bigger than this one? This bigger than this one? So you can go through and start specifying. If you're interested in strength of indirect effects, right? Say Lindsay has a specific hypothesis that, yeah, we're going to see the biggest effects here, but these other 2 are going to be things that are there. I believe that they're going to be there, but they're not going to account for as much as this one. Go through and start separating that stuff out. Okay. And then here, you can go through, if you hit center, it'll mean center variables for your predictor and your outcome. Which is handy. Okay. All right. So, but the thing to remember, running this is easy because all you got to do is once you load the macro, so load it up, so run it all. Then all you need to do is just one line of code. It just will give you everything you need. Okay. All right. So do people have your slides open right now?
Yeah.
Okay, just because it'll be hard to kind of see some of this stuff. So here is your process for the, so we walked through and had slides with your, regression model 1, regression model 2, regression model 3, right? Here, same output here, and here's your output on process, okay? So our model is process equals Y equals support, X equals PTSD, N equals utilize, total equals 1. This is gonna give us, our total effects, I think, model 4, and then we're asking for normal, our normal theory Sobel tests, okay? So here in your process outcome, you're gonna get 3 different models. Model 1, your outcome variable is utilization, and then here is your coefficient for PTSD, right? This is just your impact, okay? It's just gonna look at, so if you go through and you take a look at what we've done here is we've addressed support utilization on the PTSD. Here's my coefficient, my standard error, my t-test, my p-value, upper and lower bounds. It's identical to what we got in SPSS. Nothing magical happened there. It's just running that automatically, okay? And then we've got here a second model. Outcome is support. My predictors are PTSD and support utilization. If I go through, coefficients are identical, p-values are identical, limits are identical. This is giving me paths B and C prime here, okay? Last model, this is my outcome is support, regressed onto PTSD. This is my C path model. I go back through, I take a look, it's identical, okay? So this is what I cannot impress enough on you. Process is a fantastic tool, but it's not magical, right? All it's doing is it's just streamlining a series of regression models for you in a very nice, convenient way, so that it sort of kind of goes through and you can go through and see. But if you go through and take a look, everything that you would do by hand with that causal steps approach is the exact same thing that you're getting in process. Process is just running it in automatically, so as sequencing those out and then providing you output that is in a different font than what you would get in normal SPSS. Okay. Yes.
We don't need to use process for this class, or we do?
In this, I'm gonna have you do it both ways, just to go through and compare it across the two. Okay. With me here? Okay, cool. Then we get down into this last part of process. This is the part that, this is why you're running the whole thing to start with, okay? So you get a total effect of X on Y. This is essentially your C path, okay? Again, and if you go back through and look at the previous slide with what you already did, everything's gonna line up. And then it's gonna give you the direct effect of X on Y. This is C prime. This is saying once we've accounted for a mediator, this is how these things are gonna relate to one another, C prime path. And then here, what you're gonna get is your indirect effect of X on Y. This is your path AB with your 95% confidence bound. So here is my indirect effect. This is my bootstrap standard error, and then my upper and my lower bound of my confidence, right? Process is not going to give you a p-value with this. It's just going to give you a confidence bound, but that's fine. Do we have evidence for an effect here with this based on the confidence bound? Yep. 0 is not in there. They're both negative, right? And so what we've done is it's saying that this indirect effect, plausible estimates for the indirect effect based on your percentile bootstrap confidence bounds anywhere from negative 0.015 to 0.028. Now, is that big or small? Can we make any sort of meaningful interpretations about whether that's practically meaningful or not? Not really, because it's all dependent on your actual the scaling and stuff like that. But we've got evidence for our effect here. Okay. So this line right here is the only thing that process is doing that's unique and sort of that you would be hard to do just manually. Okay. What process did here is it went through, and really it's just these 3 things. What was the indirect effect of PTSD on support through support utilization that we calculated previously? That product AB. Yeah, what was the point estimate that we got for the indirect effect? AB.
7.03.
Nope, so that it would be that AB pass. Just taking the product path A and path B. Jim, did you find it?
Wait, sorry, on the SPSS output or?
On the SPSS
Okay.
output, yeah. We went through and when we calculated Sobel.
We calculated AP when we were doing the Z score too, didn't we?
Yep.
Okay.
Yeah, so what was that AB coefficient?
Negative 0.021.
Okay, yeah. Negative 0.021. It's the same thing. The point estimate that, the point estimate for your indirect effect that process is giving you is just the exact same that you already calculated. So not even that's new, right? You already have that, okay? The only thing that you're getting is this bootstrap standard error and the bootstrap confidence bound. Okay, yeah, Johnny.
So with like the Z score equation, the AB divided by our standard error AB, would we divide?
Yes, you could do that. And so the question is like, could you take the point estimate for your indirect effect and divide it by your standard error to get a test statistic? You could, but they wouldn't, I don't know what you would compare it on, because it doesn't follow a normal, like, I don't have a p-value distribution that you can go through and put that on, right? So what we would do is we would just focus on confidence bound here. Okay, so again, I think it's important to recognize that, so what our systems are doing for us that's unique and sort of to the program, and what's just stuff that we would have gotten anyway, right? In this situation, it's just these three numbers right here. Out of this whole output, it's just three numbers are the only thing that process is. Now, process will give it to us automatically as all part of the output, right? But it's not anything that we couldn't get through just walking through those sequence of 3 steps, okay? But what this will do is it gives us this confidence bound, starts to give us a more precise sort of guess for plausible values for that indirect effect, as opposed to using that test with the Sobel. Yeah.
Last quick question.
Yeah.
With the negative 0.021 like effect, I'm just trying to think about like what that practically means. Like, is it like, it's not a slope, is it? So then what is that?
It doesn't have a strong conceptual interpretation, right? You can talk about this it's just kind of a raw metric of the indirect path between sort of these two variables, right? And so there's no like literal interpretation. I can't look at that and make a clean interpretation about what that really means, like I can with a regular regression coefficient. It's just kind of a stand-in to say, like, is it 0 or is it likely 0 based on the data that we have? Okay, so here, what we would do in terms of reporting is we just talk about this as based on 95% percentile bootstrap confidence bounds. We have evidence for an indirect effect of PTSD on support through support utilization. And then here's the effect, here's the bounds. And so again, like, this is why people are working on trying to get good metrics for effect sizes, because that would be helpful in terms of like thinking about, is this big, is this not, you know? This is where, and for even with this, right, this is where maybe that kind of Dwyer thing where we went through, and if I just take this and divide it by the total effect, that gives me a percentage of the total effect that's being accounted for. I mean, that's at least something that makes some sense, right? So a lot of continuing work to try and capture that indirect effect or the magnitude of the indirect effect. But Johnny, yeah, no literal interpretation of that coefficient is something like we would interpret as in a regression coefficient. Yeah.
Dumb question, but can you show me the slide where you found negative 0.0210 on the Sorval? I can't.
Right. So AB is just path A times B.
Oh, it's just when we, okay, that's what
Yep.
I did.
And so, yep,
Alright, thank you.
there we go, no problem. Yeah, and so here again, if we take A path, negative 0.251 and multiply it by negative 0.084, that gives us to. So again, process, a fantastic tool and a really nice efficient way to go through and run this stuff. The only thing that I would say is sometimes people like, and same thing, you can set this up to run a moderation analysis and it'll just dump it all out. And for this set, a great way to go through, like, don't give me a process output, but if you went through and ran your model and then just wanted to rerun a process to see if you turned out the same way, it certainly should, because there's nothing going on in process that's different than what you would do otherwise, right? Same thing here. The mediation is a little bit different. And if we get into conditional indirect effects, it will go through and run these bootstrapped, and that's a very, very cool thing to go through and do. It just sometimes people get weird about like, oh, you have to run a process. It's the same thing. Like it's just like, it doesn't matter. So, you know, in terms of how things are going, right? So, yeah. And then again, finally down here, here is your normal theory test. So again, here's your effect, which is identical. And that's just your Sobel standard error, right? And then here's your z-test and a p-value, just using normal theory stuff, right? And if we go through and we take a look at the standard errors that they estimated there between these two, it's pretty close, right? You got a reasonably sized sample and pretty big effects here, so they're going to be close. But again, same. And even here, you can see maybe you make an argument about like slightly more precise with this than that, or at least in terms of smaller standard error.
What if you run this model and your process output, instead of having like the coefficient, it says model LL?
That's a model log likelihood. Are you running this model or are you running a different model?
No, model, yeah, this model, or,
Hold up, let's hold up on that real quick. Okay, yeah, Johnny.
With the normal theory test,
Yeah.
is that essentially just the same exact like indirect effects test without bootstrapping?
Yeah, it's the same one we calculated.
I just want to make sure.
Okay, so here, and you've got this in sort of stuff that's posted on the course website. If I go to, just to kind of show you what this looks like. All right, here's the mediation exercise. You have this data set sort of in your stuff. You can go through and pull this up. But then also here you've got your process macro, okay? This is just a giant, super complicated series of commands. You don't need to worry about what they're doing, how it's put together. You for sure don't need to change anything in this, just leave this alone, okay? And all you need to do is go through and highlight all of that and go through and run. And what this does is it just loads this up into SPSS. So now SPSS in your syntax file can go through and read the command that you'll go through and drop in with this, okay? Now, yeah.
Is it like a one and done, like you run it once and it's there, or do you like have to run it every time you use process?
That's what I was just gonna get into, it depends, right? Like if you're gonna use, if this is a package that you're gonna use quite a bit, there are ways to go through and like basically upload that into SPSS. Olivia, have you done
Yeah, that's what
that?
I was gonna say, that I know how to do it, like, there's a way to just like add the feature into SPSS if you run it in like admin mode,
Yeah,
so you
yeah,
can do it that way.
yeah,
I was just gonna say, there's also a way to get like a drop down, so you can do like point and click,
okay,
paste the syntax, which I really like.
good. So, all of that stuff, if you want to go through and sort of get that uploaded and use that, and that's how you want to get it set up, that's awesome. You don't need to necessarily do that. Like what I don't want to do is try and have everybody upload this into SPSS and adding additional complications for the problem set. So, but if this is something you want to use, you go through and do that, that's awesome. You can go through and do that, or you can just use the macro, highlight it, and sort of run it. When you shut down SPSS, you'll just have to run it again next time you open it up. But easy to go through.
I'm not gonna shut down SPSS then.
What's up?
I'm not gonna shut
You're
down.
just gonna leave it open.
Leave it open.
Poor computer will
Yeah,
die.
I know. You know what, that's how it is. Just-
So I've gone through and ran that macro, and then. So this is all this, but down here at the bottom. Is just my line of code here, right? And that's super small, you can't see that, but it's basically the same thing that we went through and sort of had on the screen, here. Yeah, this is all, the only thing that I added with this is I requested that it give me effect sizes, so. If I go through now and run this model. Take a moment because it's running bootstrap replications. But if I look at my output here, it's just giving me all the stuff that we had talked about before. Okay, here's my first model, my second model, my third model. Here's my indirect effects, my total effect, my direct effect, my indirect effect, right? And then from here on down, it's just giving different effect sizes for that indirect effect, which there's some cool stuff going in there. We're not going to get into all the ins and outs and things along those lines. And it feels like different people will prefer different metrics for one reason or the other. That's awesome, right? But we won't get into it too much here. Down here's your normal theory stuff. And so really nice, really, I mean, simple mediation is not hard to do, or not hard with just the causal steps approach. I mean, it's three very simple regression models, right? And then even calculating your Sobel test, and then you can calculate confidence bounds with that standard error if you wanted to, right? To go through and do stuff. Process is nice though, because as we start to add on and do more things, it starts to do that in a much more accessible and efficient way than what we've done in the past. All right, questions about this or the use of process? Anything like that? Again, it's nice, it's just one line of code. Just make sure you got the variables plugged in there, got your names, variable names put in there, and you're set. Feeling good about this? Okay, cool. So extensions, right, of the stuff that we've gone through and done. We can do moderation with higher order terms. So if I want to have three-way interactions, cubic quadratic functions, things along those lines, and specifically modeling non-linear relations between different variables in my model, I can go through and do that. Aiken and West talk about some of these procedures and things along those lines. Really cool stuff. You don't see it a whole lot, probably because as we start to go through and create some of those higher order interactions, they start to become very difficult to detect for reasons we'll talk about in a moment, but some cool things that we can do there. We can talk about mediation with covariates, right? Starting to set up a sequence of models where we're going through and looking at the indirect relation of X and Y controlling for other things, right? This is stuff that you can set up in process, but also if you make the jump into structural equation modeling, path modeling and things like that, it's a really cool way to go through and build in interesting sort of sequences of equations and models on like sort of testing very specific ways in which variables relate to one another. We can have multiple mediators. This is something that's kind of a pain and difficult to do with a straight causal steps approach, but very easy to do if we're thinking about things in terms of indirect effects and multiple influences or multiple factors that may account for the relation between X and Y, right? So Johnny, like your McNair project was basically this, just in an SEM framework. So we had just a bunch of missing data that SEM accounts for that a little bit better than process. That's the one thing with process. Again, everything is OLS regression, okay? And so if you have missing data or things along those lines, it won't account for that. It will just use the set with full data, right? And so if you've got a case where you've got missing data, then sort of an SEM framework is a nice way to go through and look at that, because assuming that your data are at least missing at random, it will go through and provide unbiased estimates there. And then what we can look at is traditionally what we used to talk about in terms of moderated mediation and mediated moderation got a little bit confusing and sort of like felt like we're all kind of turned around talking about the same thing. I think one of the big contributions of Hayes's work is simplifying this language to just talk about conditional indirect effects, which is kind of a nice way to go through and talk about this. In the late 90s, early 2000s, there was a whole bunch of stuff talking about moderated mediation versus mediated moderation. Turns out mathematically they're identical. There's not a difference between these two. And so just different ways of going through and talking about this situation. Here, Jalen was asking a question about a model. Here would be a very simple case, right? Where we have a mediated path, right? But what we've got is a different variable that we're thinking maybe changes the nature of that indirect effect, right? And so here, if we've got a grouping variable, let's say condition 1 versus condition 2, what we're saying is the strength of that indirect effect differs for group 1 versus group 2, right? And what we can go through and do, and the process makes it quite easy to go through and test this to say, do I have evidence for differences in the strength of the indirect effect of X on Y through M across these two different groups, suggesting that perhaps this, yes, does account as a mechanism, but it maybe only does so for some groups and not others, or is stronger for some groups and not others, or maybe is an opposite direction for some groups or not others, right? Again, this is not magical, and so the way we would go through and take a look at something like this, if we were to plot this out, is essentially looking at, here's X, and here is my moderator, and here is X times my moderator, mediator, here's Y. Okay. Here's essentially what that model looks like if we were to just like write it out in regression terms, right? Diagram from a sort of conceptual standpoint, this is a nice way to kind of go through and illustrate what's happening. But essentially what we're doing here is we're just looking at including this moderator as moderating this first leg of this relation. And so my test of my moderated indirect effect is going to be right here, right? So again, if we start understanding like what's actually going on with these models and sort of understanding how they sort of start to pull apart, the one thing with process is it's going to dump a whole bunch of stuff on you, right? So you want to make sure that you understand what's going on, what I go through and interpret. But again, it all breaks down to simple regression models because it's all LS stuff. So just going through and making sure that you understand what's tracking and things like that can be really useful and powerful tool.
That's a mediated moderation, right?
Or moderated mediation or conditional indirect effect. Yeah, that's exactly what this is looking at. But we can go through here. I could say that this moderates perhaps this path, but maybe also that path as well, right? Or I could have sort of moderation of all three paths or some combination of stuff, right? That now we're getting into a conceptual question of how we think these variables are actually related to one another. All right. Just general thoughts about reporting regression analyses in papers and stuff like that. Always provide means and standard deviations. It's just you're doing people favors down the road, right? And it helps contextualize your sample to understand like where your sample is relative to other people who may have done some stuff. Correlations, these are nice index of bivariate associations. It also helps with diagnostic stuff, be able to help see kind of like, well, what happened. And so this is the bivariate effect. What happened when we drop this into the regression model, going through and seeing stuff. Model R squared, again, like I said, psychological and stuff that we do, we're rarely super concerned with this, but it's a nice thing to have. Standardized effects, unstandardized effects, both of these are gonna be good things to have. Standardized effects are nice because they kind of give you a sense of relative weight within the model. Unstandardized effects are nice because you get a nice literal interpretation and are better for comparing effects across studies. Confidence bounds for your unstandardized coefficients help to give us a sense of precision, right? And so model supported effects, and then some effect sizes. Squared, I like squared partial or semi-partial correlations or F squareds in terms of stuff. Squared semi-partial correlations have a nice practical interpretation. F squared doesn't have good practical interpretation, but it is your formal metric of effect size for regression. So if you just have those listed in the table, you're doing someone else a favor because then they can just go through and use that for power analysis things. Okay. So some things to think about there. All right. Last thing we want to do is just catch up on those last slides that we didn't catch last week. And just a quick, so this is just going to be a quick note on power and reliability stuff, right? So we had talked about how moderation analyses are notoriously underpowered, okay? What ends up happening when we're thinking about measurement error in terms of our assessments? Think about this as poor score reliability, and this could be measured through a number of different things: internal consistency, test, retest reliabilities, things along these lines, right? But remember that a primary assumption of our regression model is that we've measured X's without error, okay? Now, we never do this, right? But it's an assumption, and what will happen then in bivariate analyses, if I'm using measures with error, if I have error in my predictors, what it's going to do is it's going to attenuate estimates of my association. Now, multiple regression gets more complicated, but in general, thinking about this as starting to decrease the precision of my estimates. And if I have more error in my estimates, it makes it harder to detect effects that I'm going to detect. Right? Again, multivariate analyses, it's sort of more complex. But when we've got our interaction effects, and I've mentioned this last time, if I have reliability less than 1 for my interaction terms, it's going to generally attenuate estimates of my population coefficient in that centered solution. Okay, so if I, in general, not that there aren't exceptions, but in general, as the reliability of my interaction term decreases, it makes it harder to go through and detect that because I'm going to underestimate the effect of that interaction. Okay, and what we know is that the reliability of my interaction term, or X times my moderator, is equal to the product of the individual reliabilities when X and M are uncorrelated. And if X and M are correlated, it increases the reliability a little bit, but not a ton. So in general, you should be thinking about the reliability of your interaction term is going to be a product of two base variables, right? And so anytime I'm multiplying a decimal by another decimal, things start to go down really, really quickly, okay? So again, I had talked about last time, if I got reliability of 0.8 for this measure and reliability of 0.8 with this measure, feeling pretty good about that, right? I'm like, okay, got good reliable measures. I multiply those two things together to create an interaction term. Now all of a sudden I've got an interaction with a reliability of 0.64, which I should probably be less excited about, right? And so basically what we have is compounding error when we're creating these interaction terms to test moderation, okay? Now, how does this go through and impact our effect size and power, right? When we're thinking about F and P, or F squared and my partial squared partial correlation, these are related, these are kind of the basis of determining statistical power for stuff. Semi-partial correlations, they don't hold a linear association. So for power considerations, we kind of set partial correlations over to the side, right? But when we're thinking about our regression models, right, one thing to think about here is empowering our regression models is that even though we're not super concerned typically about maximizing our R squared, if we do account for a large variability in my outcome, what that means, what does that, if I'm accounting for a large, if my R squared is large, right, I'm accounting for a large portion of variability in my outcome, what does that mean for my overall error in the model? To get bigger or smaller? Smaller, right? Because if my R squared is 0.8, that means that only 20% of my variability in my outcome is stuff that I haven't accounted for, right? And that error term there is what goes into the calculation of all my individual statistics. So if my error is smaller, what happens in my standard error? It gets smaller, right? My standard error goes in the denominator to calculate my test statistics, and if I'm dividing things by a smaller number, my test statistics get bigger, right? And so what we see is that when we're thinking about that in terms of why our semi-partial correlations aren't good metrics of something to utilize in terms of power, right? If I've got an interaction term that accounts for 1% of my variability in Y, okay? The effect size is measured by my partial correlation of my F squared is going to be greater when the lower order effects account for 80% of the total variability as opposed to when the lower order effects are only accounting for 10% of the variability. In both situations, my semi-partial correlation here is 0.01. Okay, because remember that for my effect size for my semi-partial correlation is giving me of the total variability in Y, what proportion is unique to X. And if my interaction term is only uniquely accounting for 1% of the total variability in the outcome, it doesn't matter what the other rest of the model is doing, it's still going to be 0.01 no matter what. It doesn't matter if my R squared is 0.8 or my R squared is 10 or 0.1, my semi-partial correlation is still going to be the same thing no matter what. Okay, people seeing this, why that doesn't change. However, with 80% of the variability explained, 1% increase in the residual variance results in a much larger F squared versus 10%, right? Basically what's going on, think about F squared is the same thing as like partial correlations. If I've got 1% of right, here's Y, and I've got this predictor counting for a little 1%, just right here on the edge, right? In one scenario, here, I've got everything else counting for 80%, right? Semi-partial correlation is still the same, right? Because it's looking total piece of the pie. But here, if I'm looking at my partial correlation, remember partial correlation is after we pull out everything else, what proportion of variability is left over for this? This isn't 1% anymore. It's a lot bigger piece because this is all much smaller, right? Versus if we've got a different situation where this is that, right now this is 10%. Now that's so it starts to impact my F squared, my partial squared starts to jump around a little bit. Semi-partial stays the same, right? But depending on how much variability is being pulled out by other things, that's going to dramatically change my partial correlation or my F squared value, okay? And so what ends up happening is because F squared or my partial correlations are what determines the power of my test, going through and making sure that I have a model that accounts for a good portion of my outcome gives me a much stronger and more powerful model than if I'm only just grabbing a little bit of my outcome, okay? And this also then relates into model specification, having properly specified models, like everything that needs to be in there is in there and stuff that's not, that isn't, right? And so we're not looking to jack up R squared just as a function of just to have a bigger R squared, but it helps a ton in terms of giving us strong rules. Okay, so again, establishing a good model with strong first order effects is going to be really helpful in terms of powering my moderation analyses. Okay, we did this with Layla's thesis we're looking at trying to predict, look at differences, whether or not PTSD moderated the relation between empathy and social functioning, right? So we've got sort of this specific association with PTSD and PTSD and empathy, and wanting to sort of look at how that related to interpersonal outcomes. But then we knew, because it's an experimental study, we're probably not going to get a huge sample. What can we do to increase power? Well, let's see if we can try and increase our R squared for the total model, right? And so then the task becomes, what other components, what additive components can we start, what other variables start to account for interpersonal processes that are not related to other stuff? Because we don't want to just throw in other stuff, because then it's going to capture everything and swamp everything out, right? But what are things that are unique, independent of PTSD and empathy, that might contribute to scores on interpersonal functioning, right? So then we get into stuff like family dynamic and sort of personality and things like that, stuff that shouldn't be related to PTSD or empathy, but hopefully you're going to start to sort of eat up some of that unexplained variability in my model that's going to give me a more powerful test. And that's exactly what happened, and it turned out to be sort of a nice project, right? Although we did have to go through and make strong arguments for why we had these random mass variables in the model, and had to say statistically it's important. These are things that are unrelated to anything that we're actually interested in, but what we're trying to do is account for variability here so that we can increase the power of our tests. So remember here that for our interpretive norms, small, medium, and large effects for F squared, squared partials, and partial correlations in terms of what we're seeing here, right? Now, pulling this all together, why this has such a big, why we have such difficult problems with looking at underpowered analyses with our moderation, right? Remember that our reliability of our interaction terms are going to be the product of my two base variables. And that in general, if I have worse reliability for my interaction terms, it's going to attenuate those associations. It's going to make them smaller than they would, appear smaller than they would if we had not measured without error, right? So if we go through to look at the sample size that we would need to achieve power for 0.8 for small, medium, large effects for alpha equal 0.05, in order to find a large effect, right? So this is an F squared of 0.35. If the reliability of my interaction term is perfect, okay? If the reliability of my interaction term is 1, then the effect that I'm looking for is 0.35, and I need 26 people in order to identify that in my model, okay? But let's say my effects, reliability isn't perfect, right? And say reliability of my interaction term is 0.8. So I'm gonna take, what's 0.8 squared, or what's the square root of 0.8? Okay, so I've got a variable x, x1 is 0.89, variable x2 is 0.89. I multiply those together, I end up with an interaction term with reliability 0.8. Now instead of an effect, I'm functionally looking at an effect of 0.11, and now I need 75 people, okay? If I have reliability of 0.7, right? Mandy, can you do that for me? What's 0.7? Square root of 0.7.
0.83.
0.83. So even if I have 0.83 of x1 and x2, and I'm really excited about that, I multiply those two things together, the reliability of my interaction term is 0.7. Now I need 127 people in order to power this. And I'm essentially gone from an effect size of F squared of 0.35. What I'm actually getting in my data is this, right? So as my reliability starts to go down, my power just, the bottom falls out of my power. And this is if we're looking at a large effect. I'm looking for a medium effect, right? Which is still probably an overestimate of the types of population effects we're searching for with these moderation analyses. An F squared of 0.15, go from 55, sample of 55, if I would have measured that without error, to over 250, and still 0.7, like this is not terrible, right? I've got an interaction, or I've got base variables that are with reliabilities above 0.8, but all of a sudden I have got massive sort of impacts on my model. So my population effect is 0.15, but functionally with the impact on reliability, I'm essentially needing the power for an effect of that size, right? And so this is what's happening here. If I go to small effects, right? Even with perfect reliability, I need almost 400 people, right? And then then it just gets ridiculous once we get sort of higher up here, right? So again, in terms of thinking about the consequences of measurement and having good measures and having reliable measures and good, clean experiments and really good procedures for collecting data and things along those lines. It's not just like, oh, this is a good thing that I should do, and so someone could criticize my methods. It has direct impacts on your statistical power, right? So thinking about if I'm going to go through and run these analyses, right? And these are great analyses to go through and run these moderation effects. Really cool once you get a handle on things. Fun to talk about, but thinking about from a practical standpoint, one, you should just automatically assume that you need to have big samples to reasonably detect the stuff that you're going to be looking for. And then two, thinking about how have I measured my predictors? Okay, am I doing that in a way that's sort of good, sort of strong psychometrically validated measures? And then thinking about, okay, I'm going to be looking for a small effect. I need to have as much power in this test as I possibly can. First thing I can do is just get as many people as I can get and feasibly try and get as many as I can. But like Layla's study, like it's not a questionnaire study. We actually have to run people through a lab thing, and like we can only get so many. Say we get 120, how do we go through and then jump up our power here? Well, one way you can do it in a regression model is just increase your R squared, right? Now the trick is trying to go through and find variables that are and measures that are going to go through and account for variability in your outcome that are separate from anything that you're trying to do. Because as soon as you start dropping stuff in there that's correlated, I mean, again, like you can throw neuroticism as a measure in there, and it's probably going to increase your R squared, but it's probably going to swamp out anything that you're interested in that has anything to do with negative affectivity. So it's thinking about what are the tiny things that we can do to start to chip away here to increase the power of my test, because I already know I'm going to have problems with power and reliability. Okay. And so switching back over, thinking about those three-way interactions. This is why you almost never see three-way interactions. When people are scared of them, they're like, oh, you can't interpret three-way interactions. You can. It's just so good. It's the same process working down. But the reason they don't come up a whole lot is because if I take 0.8 and I multiply it by 0.8 and I take it by multiply it by 0.8 again, now I've got something that's basically functionally not reliable at all. And it's just, there's no way to go through and actually sort of pick anything up off that, right? So thinking about as you're going through planning out your analyses, whether it's studies that you're planning from the ground up or access to data that you already have, thinking about and knowing how these models work and sort of giving yourself the best opportunity to go through and find the effects that you're looking for. If you know what's going on in the hood, then you can start pulling strings back. Okay, well, I'm probably going to be underpowered. Let's go through and see if we can increase the power here or do different types of things in order to make this happen. At least give me the best opportunity that I have to find the effects that I'm looking for. All right, cool. That's it. Okay. For the only thing that I had mentioned that you will do, and I'll give you a link, just a series of slides walking through how to calculate confidence bounds around different effect sizes in regression. That's fine. You can go through them. It's fairly straightforward. You'll need to make sure that you very clearly understand R squared, adjusted R squared, or excuse me, R squared change, partial correlation, semi-partial correlation, things like that. But you all are sort of been working with that for a while, so it shouldn't be too bad to go through. If you have questions, just go through and let me know. So this is it. Like, this is the bulk of class, getting regression stuff out of the way. Huge achievement here. So go through, keep working on moderation stuff. We'll have that due at 5 on Friday. Turn those into my box or turn them into me. I'll be hanging out in my office. If you have questions, let me know. We'll catch up to get those straightened away for you. And then this mediation stuff, be straightforward. There's not too much to that. That should be easy to tackle, when we get back from break. Sound good? Awesome. All right. Thank you, everybody. Enjoy your breaks. Have fun.
Where